Hello and welcome to the Data Engineering Podcast, the show about modern data management. Have you ever woken up to a crisis because a number on a dashboard is broken and no one knows why, or sent out frustrating Slack messages trying to find the right dataset, or tried to understand what a column name means? Our friends at Atlan started out as a data team themselves and faced all this collaboration chaos. They started building Atlan as an internal tool for themselves. Atlan is a collaborative workspace for data-driven teams, like GitHub for engineering or Figma for design teams. By acting as a virtual hub for data assets ranging from tables and dashboards to SQL snippets and code, Atlan enables teams to create a single source of truth for all of their data assets, and collaborate across the modern data stack through deep integrations with tools like Snowflake, Slack, Looker, and more. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $3,000 on an annual subscription. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's LINODE, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macy, and today I'm interviewing Chetan Sharma about Eppo, a platform for building A/B experiments that are easier to manage. So, Chetan, can you start by introducing yourself?
Yeah, absolutely. My name's Che. I've been in data science now for like 12 or 13 years. Most of that time was at Airbnb. I was the fourth data scientist there, stayed there for about 5 years. After that was first, second data scientist in many other places. And this has kind of guided a lot of my perspective on what ultimately led me to build Eppo.
And do you remember how you first got involved in the area of data?
Yeah, so I was trained as an electrical engineer and then a statistician, which ended up being a pretty fortunate combination when I hit the job market. I started out kind of more on the healthcare policy side, which was very cool to work on, such important problems, but ultimately a little too slow for me. So then I joined Airbnb, which ended up being a great experience in a lot of ways. And I think one of the things that's unique about how I think around data teams and how they should operate is that by being at Airbnb so early, kind of before the company really had embraced data as a core process, you just appreciate the problem a little bit differently. I mean, Airbnb, I think most people probably would see it as like a pretty sophisticated data shop today, but it was not destined to be that way. It was founded by designers. Brian Chesky idolizes Walt Disney. It's not the sort of place where they're naturally reaching for data at every step. But, we ultimately won that kind of culture war. And now I would say data is a hugely instrumental process to everything there. And a core part of that was experimentation, in terms of getting this process to be ingrained everywhere. So, there's a lot more to my data management background. I started out in production machine learning, worked on data tools. I open sourced a thing called the Knowledge Repo, which was a collaborative notebook knowledge management platform, and, ran a lot of experiments. But, at the core of it all, I kept thinking that if we really peeled back what made Airbnb turn the corner, it was experimentation.
So that brings us to where you are now with the Eppo project. I'm wondering if you could just talk a bit about what it is that you're building there and some of the story behind how you decided that this was the problem that you wanted to spend your time and energy on.
The reasons I wanted to work on experimentation was that, you've seen it now with a lot of these other tools. Like, there's a lot of problems a data team has to solve, and many of them have gotten a lot better. Back when I was at Airbnb, we had to roll our own data infrastructure, host our own Hive clusters, and literally had to build Airflow. But nowadays, so much of that stuff is turnkey, and you can get up and spin up reporting pretty easily within a week. You can just get Snowflake, get Fivetran or something, get data in there, dbt to orchestrate it around. But the problem I kept seeing everywhere I worked after Airbnb is that you don't build a data team to have a data warehouse. That's not the goal here. You build a data team to make better decisions, and better decisions just weren't really happening at a lot of orgs, even when you have this modern data stack. And to me, a real crux of that is that reporting, while it's can be very informative, it doesn't really have much leverage in product decision making. You'll spin up some dashboard, it has top line revenue or something like that, And, the CEO and the board are happy because they can report on the stuff, but product teams are staring at that dashboard and thinking like, I hope it goes up. I don't really know what it means for me. But once you build these experimentation cultures, once you make it really fluid and easy, suddenly every product team has an intimate connection with metrics. They have alignment on like, here's what I am trying to boost, and here's what I have done and what has not succeeded at moving that metric. And so it has this amazing second order effect of just getting people to engage with data in a serious way. And then the other thing that really made me excited around building Eppo was that when you nail experimentation, it leads to this entrepreneurial culture where suddenly people can take risks. They can try stuff out, and you can have, amazing product developments come from some engineer in the building. It's very empowering that way. But, as, most companies see with the commercial landscape, there's really not great options to have an experimentation culture like Airbnb or Netflix's. Like there's not any tool you can get. And so you see every team have to build the same thing in-house over and over, and they all look very, very similar. And so at Eppo, what we're basically saying is that paradigm doesn't really make sense. Experimentation is not a nice to have. It's a core part of a data team's operations, and everyone should have the type of tooling you see at Airbnb.
Yeah, and experimentation and A/B testing is definitely one of the perennial challenges that I hear people mentioning as they're building out their data capacity of saying, we can build analytics, but trying to actually conduct experiments, there are just a lot of challenges and points of friction. And I'm wondering if you can just talk through some of the kinds of experiments and A/B tests that teams might want to conduct and some of the sort of technical points of friction that exist in sort of the general state of the data ecosystem and in organizations that lead to this challenge of actually being able to effectively build and run these experiments and create that fast feedback cycle.
Yeah, absolutely. So kind of starting off with what types of experiments would people run? I think it's one of those interesting things. If you go to an Uber and Airbnb, every product launch basically has an experiment. It becomes ubiquitous. Now, that's not necessarily a realistic expectation for every company, but that's kind of where you end up asymptotically. But where people start out with is running experiments. We usually see two teams kind of be the tip of the spear for experimentation. It's either some sort of growth team that is, working across a lot of product surface areas, trying to boost concepts like activation, engagement, retention, or it's a machine learning team who is constantly iterating on their models, and they need to kind of validate that one model is better than another. I think it's pretty logical. This is the exact same trend that happened to Airbnb. Experimentation started on the search ranking team before spreading to more of the org. And I think it makes sense because growth and ML teams tend to be the first ones who have OKRs that are about metrics, that are around like, you need to boost this metric as opposed to shipping these features. The type of experiments they would run, ML teams iterating on models is just the classic one. For growth teams, it can be various ways of lowering friction. Maybe we don't need this additional screen. They can just go right to the checkout page, or creating more urgency. At Airbnb, we have messaging saying like, 10 people are looking at this listing, and ends up driving quite a lot of bookings. It can even be really small things. One of the things the stories I love telling is that, I was at Airbnb for 5 years, from 2012 to 2017. By far and away, the most impactful experiment we ever ran in those 5 years was this engineer made it where if you click on an Airbnb listing, it opens it in a new tab. That one little thing boosted bookings by like 2 or 3%. It was crazy. And like as much as many multi-quarter projects. So like once you get established experimentation, like all sorts of things can become tests. And, as anyone who's been part of these cultures knows, it can be very humbling to see what works and what doesn't.
And as far as the actual process of designing and building and deploying and analyzing the effects of an experiment, I'm wondering if you can just talk through that overall process and some of the sort of technical considerations that go into it, some of the design elements, the stakeholders that are involved in each of those stages of the process that goes into saying, okay, this is something that we want to test, to this is something that we have found out from this experiment that we want to actually permanently change.
Yeah, absolutely. And I'm glad you phrased it this way, because one of the things that I think a lot of tooling doesn't get right is just understanding the end-to-end of an experiment process. So, when you're running an experiment, there's basically 6 steps that happen. So first, you have to have some alignment around like, what are you going to run? We want to improve, the search funnel. We want to decrease customer support tickets. Just some idea of like, what are we even trying to solve? Then you come up with these hypotheses and you design an experiment, which is like, if we put 6 items on the screen instead of 3, we think people will find more inventory before getting distracted or before leaving the platform. And so there's an experiment design stage of saying, like, we want to test this thing out. And kind of alongside that kind of more product-y conversation of like, what is the best product to improve things, is also a statistical question of, if we want to test this thing, like, how long does it take to run? So this thing, that's called a power analysis, as probably most of your audience has come across. So you have to, run a power analysis, define who is going to see this experiment, what metrics you're going to boost, and just to make sure it's a tractable thing. Once you have an idea of what experiment you're going to run, then you have to actually run the experiments. And this is something where, again, there's a lot of challenges where actually running an experiment can be like, when you go from the world of these kind of Airbnb, Netflix tools to trying to patch it together yourself, you come across all the sort of failure modes you can enter into. There are things like imbalanced randomization, where you launch some experiment, you think it's 50%, and it's actually 51-49, which might not seem like a big deal, but that 1% off could be a very biased cohort and can ruin your whole experiment. Another thing that can happen is some sort of bug can get introduced either by your own team or by another team. These organizations are pretty dynamic in terms of the amount of product changes that are happening. So it's kind of a bummer if you're running some experiments and halfway through some bug gets introduced. Another thing is, when you're running these experiments, people are always looking at the results. Like, I think this is one of the funnier paradoxes of experimentation, where, if you read the stats textbooks, like, especially if you're using the frequent testing, the t-testing, like, you're not supposed to look at results until the end. But obviously everyone looks at these results all the time. And so, how do you make sure you can hold people back from, bad statistical practices? So all this stuff is happening while it's running. Once it's done, you need to kind of aggregate the results, report them out. Typically, this is where data scientists and analysts kind of get brought in more seriously and end up spending a lot of bandwidth. So this is calculating the overall results plus any other informative data points. And then the team has to make a decision. And making a decision, can be hard if you haven't created good alignment ahead of time. Some of these metrics can be in opposition. For example, if you're a DoorDash, like, what happens if orders go up and revenue goes down or something like that? You have to have some idea of what you're going to do there. And then kind of once you've made your decision, then, you want to disseminate the knowledge because, like I mentioned before, I worked on the knowledge repo, which did a lot of work around kind of creating a common knowledge base for people to draw on. One of my big takeaways from that is that institutional knowledge, the sort of stuff that, people talk about to others around what made a company succeed, a lot of that comes out of successful experiments, because experiments really clearly show that this thing succeeded and this thing didn't. It lets people really know what, tells the story of a company there. So 6 steps, quite a lot of depth to each of them that involve cultural barriers and technical barriers, statistical barriers. We're trying to make all of that go much more fluidly so that you don't have to take like a Reforge class or take extra training to actually run this process.
It's interesting that you mentioned the sort of potential negative impacts on various metrics where you're conducting an experiment to say, I want to increase conversions, but maybe those conversions are actually of a lower total lifetime value. And so your long-term revenue actually dips despite the fact that you're adding more people at the top of the funnel. And I'm wondering if you can talk through some of the types of sort of unintended consequences and some of the statistical errors or misinterpretations that commonly crop up in the process of actually building and analyzing these experiments, and some of the ways that you can actually identify and guard against some of these negative outcomes from the experiment, because you're saying, I'm looking at this number over here, but the number that's actually changing is something that I'm not paying any attention to. And so I might actually not see that there is an impact from this experiment, but not the one that I'm looking for.
When we talk about these kind of failure modes, there's quite a lot of them. And I think this is one of the things that doesn't quite get appreciated from people hand rolling it. So, at the basic level, we talked a little bit around some of the diagnostics you need. Like when you're running an experiment, you think you're testing one thing, which is just, your product idea, but you're actually testing not only your product idea, but your execution of that product idea. Did you build it without bugs? Did you build it with good design? Was it a viable product? And then you're also testing your infrastructure. Are you randomizing properly? Are you using the right way to calculate a metric and not the wrong way to calculate a metric? And are you kind of noticing if experiments are interacting? So there's a bunch of stuff around the general health of an experiment that you need to handle. But even outside of the general health, there are ways in which kind of organizations will, run into trouble. So one of the big ones is early stopping. So this is something that gets a lot of attention in stats circles, where most companies are using the frequentist t-test, z-test paradigm for running experiments. If you're running those, then you're not supposed to look at the results until the end. But most organizations do. They see it go green. There's not a data scientist who's kind of holding everyone back, so they stop it early. And if you do that policy where you say, like, this experiment is supposed to run for a month, but a weekend it looks green and I just want to move forward, you're going to end up with a lot of false positives. It's going to basically take away a lot of the benefits of running experiments. And there are ways to mitigate that, both from statistical methods or from processes. But, that's a pretty common one. As insidious as that is, this is something that I think doesn't get appreciated enough, is actually running the experiment for long enough to detect a signal. So one of the kind of more sad stories for me was my most recent gig was at Webflow. And when I joined, they had just finished this experiment. They finished it maybe like a month or two before I joined. And it was on this product that I thought was a really good product. They had a pretty good set of research. They had incrementally built it. They had done the product work in a good way. They ran the experiments and it didn't show an effect. And everyone was very disappointed. The team was kind of steadily, disbanded, kind of turned into the resources reallocated. But the experiment, they only ran it for a week. And if you did the math on it, it was supposed to run for 2 months or 3 months. It was just not nearly enough time to detect an effect for this data set. And that's too bad because, if the organization internalizes it as saying this product didn't work, but in actuality, it just didn't follow the practices you're supposed to do for experiments. So, that's another one. Another really common pitfall is looking at the right metrics. So, you alluded to it in terms of short-term, long-term effects of a lot of the tools that people purchase off the shelf. They only tell you kind of widget clicks as metrics. You can only use these click events and talk about conversions that way. But if you talk about the metrics that a business care about, they can be a little bit longer term. They can be things like net subscriptions, retention, activation, these sort of things. And you need a system that can actually use those and encourages you to do them. The other thing is guardrail metrics. So maybe your experiment boosted revenue, but it also increased customer support tickets by making people very confused. So having some sort of policy of saying, like, every time you run this experiment, you need to also check these other metrics just to make sure our system stays healthy. So, quite a lot of things you want to get right with your experimentation program. We try to make it very easy so that, like, the product teams who are running experiments don't have to know all of those things. They just kind of get this health report. They automatically get nudged to the good practices that lead to signal at the end.
In terms of the design aspects of experimentation frameworks, that's definitely something that can help with guiding people into the kind of best practice of how to actually build and think about these experiments. And I'm wondering, what are some of the design and user experience principles that you focused on in the Eppo platform to improve that overall workflow of building and analyzing the experiments and helping to make people aware of some of the pitfalls in their kind of logical approach to the experiment, the ways that they're conducting it, preventing people from stopping it early by raising a warning flag saying, don't do this, you're not actually getting the numbers you think you are, and just helping to kind of educate people along the way?
So there's 2 high-level principles we operate with. I can go into some of the more tactical things. So the 2 high-level principles we really believe in are, one is that people need to be given the decisions they're equipped to make. So every company has, a finite set of what I would call experiment specialists. These are people with statistics training. Maybe they've run experiment programs before. They can be senior product leader, senior data leader, engineers, whatever it might be. But it's a finite set. It's not enough to cover the appetite for experiments everywhere. We want those people to have their decision-making scale across the org. They set the rules of engagement, like, here are the metrics that people are going to use. Here's the statistical regime we're going to use by default. Every experiment will have to run for at least 2 weeks. and ideally, you finished it to completion, a bunch of these sort of principles. And then all the rest of these product teams, when they run experiments, they don't have to think around like, am I using the right revenue metric? Like, have we run a power test to figure out how long to run it? Like, am I reading these results correctly? And so in general, we say that, experiment specialists set the rules of engagement. All the product teams kind of can turn the crank within that kind of guided sandbox with guardrails. Now, tactically, what that means is there are some things which we just automate. So, for example, the power analysis thing is, very core to getting signal out of an experiment practice. So we're just automating that. Create like a little progress bar so you can just see like, to get, signal according to the default set by the specialist. Typically that's like, 80% statistical power. Then you need to run this long. And we show you that you're 70% complete or whatever. The other things we do is allow people to structure metrics with guardrails versus, other metrics you might use in a more bespoke fashion. Another thing we do is, I alluded to it before that the experimentation has this central paradox, which is that, from a statistical hygiene standpoint, you're not supposed to look at that many metrics. There's a whole problem called the multiple hypothesis comparison problem, where like the more things you look at, the more likely you're going to get some false result. And so that's the statistical point of view, is that you're not supposed to look at that many things. But anyone has ever, run experiments in an organization knows the organization wants to look at a lot of things at a lot of points in time. And so how can you acknowledge that both forces exist, but lead to better decision making? And the way we do that is we have a much more opinionated reporting interface for what we call decision metrics, which are the things you're going to make your decision off of, the primary metric plus guardrails. And then for all these other kind of more bespoke metrics, widget clicks, funnels, whatever, slice and dice, we create a separate BI space where, you can go and explore those things, but it's kind of understood that that's where, the stuff that is closer to explanatory, setting up the next experiment to succeed versus making a decision off of, all that stuff exists in this Explore tab. So in general, we try to say we use a mixture of automations of things that should happen, design nudges for things that we think should happen, statistical practices that kind of just take certain problems off the table, such as using sequential analysis in Bayesian. There's more to it. But yeah, those are the general principles is, make it so that people don't have to know all the complexity of experiments to run experiments and, design these interfaces to, be able to scale to an organization.
One of the interesting things about the idea of experimentation, so my kind of initial introduction to this was through Optimizely, which is a very narrow scope of experimentation that just has to do with the UI elements within a given product. But because you're dealing with experimentation at the product level and it's potentially much more expansive in terms of the types of things that you can test, I'm curious how that plays out in terms of a multi-service or a multi-product experiment where maybe you want to say, we want to see what the impact is on our overall revenue if we make this change across all of our product line. Maybe you're updating your branding and you're doing it selectively, and some of the ways that you have to think about collecting that information and being able to store and aggregate it and be able to build an effective analysis on top of that more kind of broad-based set of data versus something that's coming from within the confines of a single application.
The way we think about this stuff is that one of the overriding trends that, underlies probably even this podcast is that we have this emergence of the modern data stack where there's a lot of tools to get everything into your Snowflake, BigQuery, Redshift. And that can come from your Optimizely. It can come from your own in-house feature flagging service. Maybe you just offline created a 50-50 split of users and you're using that. But whatever it is, it's very easy to get that into the data warehouse. Similarly, we have seen an overwhelming number of tools that now say when you are pulling metrics, whether it's for the CFO or for your product manager, that's also going to live in Snowflake, BigQuery, Redshift. And so what we've done is the entire backend of Eppo is your cloud data warehouse. So we do all of our calculations there. We pull both the experiment exposure data as well as the metric data from there. We have a pretty rich kind of semantic mapping of how we can utilize that data that was vetted from our time at Airbnb. So what that means is that if you have multiple points of sale, so suppose you have a retail operation and an online operation, and revenue is pulling from multiple of these things, or suppose you have, for experiments, you have a client for your server side and for your mobile apps. All that stuff, the data can still end up in your data lake and we can utilize it. It's kind of built modularly to allow for a kind of more complex experiment setup.
And can you talk through a bit more about how the Eppo platform itself is implemented and some of the additional systems or services that are necessary to be able to actually feed into Eppo to be able to build and manage these experiments, particularly thinking in terms of things like feature flagging or the specific business intelligence layers that you're able to hook into and things like that?
Today, we wanted to build an analysis-centric experimentation platform. And that naturally led us to really focus on the diagnostics, the investigations, the results reporting. That means that our product today is built with a bring your own feature flagging, bring your own warehouse model. So we actually sit on top of Optimizely, LaunchDarkly, or your own feature flagging service. Whatever you're using, we're happy to sit alongside that. All we do is we pick up that data from the warehouse. So that naturally means, the product today, you probably need something like that, or we're happy to set you up with an open source solution to get going on your feature flagging. The other thing with the way our system is built is, we primarily sell to data teams, and that's because we kind of built so much towards this world of Snowflake as the center of the universe or BigQuery as the center of the universe. That also means that you should probably have, your dbt Airflow layer to get a lot of value out of, our tool. It's not a strict necessity, but, it does mean that there is someone in the org who is thinking around what the right representation of metrics should look like. So that's usually the point at which organizations start thinking more seriously about experimentation anyway, once they start building a data team. And so we kind of naturally slot into that maturity curve.
In terms of the integration points that are available for hooking into Eppo or for Eppo to be able to feed into other systems, I'm wondering what your initial conception was as far as the overall scope of the Eppo platform and where you wanted to rely on some of these external systems and some of the ways that people can drop Eppo into their existing environments and hook in some of these different signals and metrics to be able to feed into the overall experimentation process.
In terms of, the hookups and integrations, today, it's very simple. It's that all you do is just link us to your data warehouse. From there, what you have to do is just configure a bunch of the metrics and dimensions into our system. It basically says, here's how we calculate revenue. Here's how we calculate purchases. Here's how we calculate activations. Our underlying abstraction is SQL. So it's a similar paradigm you might see in, some of these metric layers or kind of LookML. What's great is that, SQL is widely accessible language, and it's pretty expressive. So, even if your warehouse is in some varying state of cleanliness or having canonical tables, we can work alongside any of those sort of systems. You just give us a SQL snippet. All it has to do is give us fact tables. So, this amount of revenue was accrued at this time. These entities were involved. There was a user. The user purchased an item. And from there, what we do is we can build a pretty rich experiment-centric BI layer where you can look at results not only overall, but you can slice them by various concepts. You can slice them by, the typical things like country or device, but also more warehouse-specific things like user persona or first-touch marketing channel, stuff like that. And then the other crucial part about this is that experimentation is a system that continuously involves configuring new metrics. A new team starts adopting it. They want to drive some other kind of internal metric. They want to get that configured into the system. So we invested a lot in making it very easy to add more and more metrics, add more and more dimensions so that each team can get the sort of analysis capabilities they need.
Modern data teams are dealing with a lot of complexity in their data pipelines and analytical code. Monitoring data quality, tracing incidents, and testing changes can be daunting and often takes hours to days or even weeks. By the time errors have made their way into production, it's often too late and the damage is done. Datafold's proactive approach to data quality helps data teams gain visibility and confidence in the quality of their analytical data through data profiling, column-level lineage, and intelligent anomaly detection. Datafold also helps automate regression testing of ETL code with its data diff feature that instantly shows how a change in ETL or BI code affects the produced data, both on a statistical level and down to individual rows and values. Datafold integrates with all major data warehouses, as well as frameworks such as Airflow and dbt, and seamlessly plugs into CI workflows. Visit dataengineeringpodcast.com/Datafold today to book a demo with Datafold. Beyond the technical requirements for being able to run these experiments, as we've noted, there are a lot of organizational elements to it and community of the design environment. I'm wondering if you can just talk through some of the decisions that need to be made when figuring out what kinds of things you want to change and how to measure the impact and what you actually want to change to be able to get the desired outcome, because there can be several orders of removal from the metric that you actually want to impact versus the change that you actually want to make.
The cultural side of experimentation is part of the thing that gets me excited around this, is like the intersection of tools and culture. If you're trying to set up an experiment, especially your first few, you hit on exactly some of the initial questions you should ask, which is, what metrics are you trying to improve? And then mathematically, how long would it take to measure those metrics? Some metric, maybe your sample size is not quite that large. Maybe these metrics are very lagging. And so you have to have a kind of candid conversation around, like, even if we ran this experiment, if it took 6 months, is that, a good practice for us? Now, if it is 6 months, there's a few levers to pull, and I think this is something that you see in a lot of even outside of using Eppo, where there's a whole world of calculating indicators, which are what are kind of more upstream actions that the data team has shown is, highly correlated to long-term outcomes. And so when you see these things like LTV models, like early lifecycle LTV models, it's sort of related there. At Webflow, for instance, we saw that even though it's a SaaS business and, seeing if someone's going to subscribe and retain takes months, the things that were really indicative of getting value were, publishing a site and getting traffic onto it. If Webflow is a website builder, so once someone got the site out there, once people were looking at it, then, good things tended to happen. And the steps on the way to that were also just repeated publishing. So, these are some metrics that, you might use for your early experimentation efforts. But the point I want to emphasize with that is that I think most people get the data science statistical standpoint on it, which is find metrics that are, correlated and then can be proven causal to long-term effects. But there's a organizational cultural side, which is you're trying to kind of build organizational alignment that this product is good and this product did not succeed. So you need to find the metrics that kind of have a good audience among product leaders, among, the C-suite. Basically, as an experimentation effort, your ability to drive organizational change is going to be through alignment building, which happens through picking the right metrics.
In terms of actually building and running these experiments, obviously there's a bit of experience that's required to be able to actually do it effectively. And I'm wondering if you can talk to some of the ways that organizations who are early in the journey of actually building and running these experiments can kind of flex that muscle and build up the capacity to be able to more effectively run these experiments and more intuitively understand the knobs that they want to twist to be able to actually have the desired outcome.
I think one of the things we have seen in most companies, and I've personally seen at every company, is there's a experiment maturity curve that you have to go through before you start kind of building alignment, showing clear ROI. Reforge actually emphasizes this a lot. So if anyone has taken that class, but basically to have an experiment practice, there's a crawl, walk, run progression you have to go through. And it basically, what it is the way Reforge teaches it, learn to test, learn to learn, and then learn to win. So, digging into that, the first step is to just learn how to do an A/B test at all. Learn to do one that's healthy, that doesn't have a bunch of bugs in it. I have been on multiple teams that have had OKRs of run one experiment this quarter. And it sounds sort of funny and facetious until you start seeing getting proper randomization, building a thing that didn't have a bug in it, and actually completing and understanding the results. There's a lot of pieces that have to fall into place there. So, the first step is learn to test. And this is something where I think Eppo, and tools like that can really, really help you out. The second piece is to learn to learn. So one of the things around experimentation is the second you start measuring things, you realize it's like how few of the things you're launching are actually improving things, are actually improving metrics. There's been a lot of papers coming out of Google, Microsoft, Netflix, Airbnb, whatever, that basically show that, all the things you launch, usually around a third end up successfully moving metrics positively, and another third end up doing it negatively. So, the two things you can think from that are, one, you need to be a little bit humble around what is actually a successful product. And two, you need to figure out, how do you quickly get to a successful product? So what ends up happening is you need to learn to learn. You launch these experiments, they often end up neutral or negative. You need to figure out what happened. Is there some reason? Did it work for some users and not other users? Did it work for certain regions, not in other regions, for different viewports, for different user personas and their goals? And so what ends up happening is these organizations will send their analysts into a bunch of Jupyter notebooks to try to unpack this experiment in 1,000 different ways. At Airbnb, we built a bunch of BI type of workflows to be able to do these investigations yourself. And that's a similar thing with what we've done with Eppo, is make it very easy to understand what happened, even if it was not a positive experiment. So first you learn to test, make sure that the experiment runs successfully. And then you learn to learn, where even if it ended up neutral, you understand what worked and what didn't, what would be the reason why it didn't work. Once you can do that, that's when you start reaching these places where you can consistently show successful results. That's when you learn to win. You've understood how to run good experiments. You've understood how to do good product development. And now you can, start to show some of these metric lifts. And so the problem is that, this is a maturity curve that basically everyone has to go through. When you're fighting your tools along the way, you're kind of burning the clock a little bit. If a team wants to take an experiment-centric approach and 2 years in, they haven't learned to win yet, it's going to be hard to justify continuing it. So I think the teams that want to run experiments would do well to take every measure they can to quickly get through this learning curve.
And another challenge as organizations do become sophisticated and very experiment-driven is that at some point you're going to have a multitude of experiments that are running contiguously, and understanding what the actual outcome is, where one user might be bucketed into 3 different experiments, and how is that confluence of experimentation going to actually impact the numbers that you're trying to measure for each one of those individually, and just some of the strategies that you've seen for being able to effectively manage that large number of experiments and prevent them from conflicting and colliding with each other and causing mixed signals where maybe numbers dropped not because of the experiment that you were running, but because of a different experiment that happened to be on the same page.
So this is a tough, deep problem. We call it experiment interaction effects. So if you have a really large sample size, if you're like Facebook or something like that, the way this can typically happen is that your experiment assignment tool, your feature flagging tool, will have a concept called layers, where it will say a user can only have one experiment that is in the same layer. So it's just an organizational principle that says here's a set of experiments that are all happening in the same place. We're going to make sure that users are only experiencing one of those experiments and not multiple of them. So that's a nice, clean way to do it, but it relies on having a very large amount of sample size. For a lot of these companies, even just getting one experiment delivered to the whole population to finish reasonably is a hard thing. And so what you'll see, and this is what we did at Airbnb for a long time, is that a lot of companies will just kind of put it all out there, let people experience multiple experiments, and then after the fact, try to look back and see did something funky happen, And so the typical way you do that is you do these kind of 2 experiment comparisons. You essentially make a 2x2 grid of saying for a given metric, for people who saw neither experiment, what was the effect? For people who saw one of either experiment, and then for people with both, what were the effects? And hopefully it's something that's kind of closer to additive than an opposite effect. So it's a kind of crude process. What I've seen, but honestly, the thing I've seen happen the most is just people ignore the problem and they just keep going. But for the people who care about the problem, that's the effect I've seen people do the most. And we're building tools to make that two experiment comparison very easy. The strategy that I'm actually excited about for Eppo, we're going to be building this in the future, is to try to do some sort of automation around it, which is, this is a strategy I heard from an experiment builder at Stitch Fix. But to run a daily regression where regress against a certain metric, let's say revenue or something that's broadly applicable. And then you include covariates for each experiment and then every pair of experiments. And what's interesting there is that if a covariate for a pair of experiments pops, then, there's probably something weird there. I think in general, one thing to keep in mind is that for these experiment interactions, you're looking for a bug. You're looking for something where one experiment has ruined the other. And so, most solutions end up looking for large effect sizes in this problem.
And as far as teams who are trying to actually get used to this experimentation flow and understand how best to deploy their feature flagging and bucketing for the users who are the subject of these experiments and figure out how to actually introduce useful events and metrics as a result of the interactions that those experiments are having. I'm wondering if you can talk through some of the kind of learning curve and points of understanding that are necessary to be able to actually make this effective, and maybe talk through some of the overall workflow of onboarding Eppo and making sure that you have all of the requisite pieces in place to actually be able to use it to its fullest effect.
In terms of the pieces that you need and to run experiments correctly, here are all the pieces. And what I'll say is that most companies have maybe one purpose-built piece and everything else is very ad hoc. So, you need a feature flagging tool, some way to randomize traffic. And that can be, an optimizedly launched darkly. It can be something you do in-house. I've seen people do very basic things like just using the last digit of a user ID, although that has its own potential pitfalls. But you just need some way to randomize traffic and deliver a different experience to both sides. The other input you need is some way to kind of utilize and govern a very diverse set of metrics. So, these metrics should include the core business things like, revenue, activations, engagement. It should also include a bunch of product analytics, because the second you start digging deeper, you're going to want to know, was there a drop off in the funnel? Did people even see the widget I made? Did they even interact with it at all? So you need some way to utilize and govern a whole wide variety of metrics. Then these two tools combined with a whole bunch of data pipelines. So first you need to do the basic thing, which is, take your primary metrics and see if it increased and run a stat test on it. And then from there, you also need to automate all these diagnostics. So, is the randomization proper? Is there an inordinate number of people who are seeing both sides of the experiment and that are getting thrown out? Are we handling people who are cross-device, who aren't logged in yet, being able to pair them with metrics appropriately? And then the last set of data pipelines are around investigations. So, I alluded to it before. Most experiments aren't going to work. And in that world, you need to understand kind of what happened. Did it work for some people? Did it not work for some people? So there's a bunch of different data calculations you have to do. And then once all of those things are calculated, you need to put together some way of reporting, some way of conveying the results to the organization. And this is something where there's a lot of companies out there who reporting interface is not consumable to anyone who's not a data scientist. It's some kind of private internal dashboard that people will look at and then copy paste the results into Slack or something like that. And that sort of thing, it's a pretty low trust process when you can't engage with it yourself. And it means that an analyst has to be involved in every single experiment. You basically have an experiment to headcount ratio you have to maintain. So those are all the pieces. Now, companies end up either putting together an experiment team, a cross-functional, 2 backend engineers, front-end engineer, data scientist, PM sort of thing to make it all work together. Or they'll use Optimizely thing, pay $200, $300K for it, and then also roll their own data infrastructure to build out the kind of metrics and data pipelines to calculate results. And try to reuse Looker or Jupyter Notebook something to do the analysis. So for Eppo, the way we think around it is what you need is today you need some sort of feature flagging system like an Optimizely or in-house thing, and you need a cloud data warehouse. So Snowflake, BigQuery, Redshift. That cloud data warehouse should have a transformation layer, a dbt or Airflow. So those are the 3 ingredients. Kind of from there, we can operate pretty well. You just configure your metrics into our system. You connect us to the data warehouse, and then we do all those data pipelines. We give you reporting that is kind of widely consumable, shareable, that has like a viral effect. And we create a system where, again, specialists can establish the ground rules and everyone else can turn the crank and run reliably informative experiments.
In your experience of building and growing the Eppo product and working with your customers, I'm wondering what are some of the things that you have learned about experimentation that you didn't encounter in your own work, and some of the sort of ideas and assumptions that you had about the overall space that have been changed or challenged in the process?
In terms of ways in which people are using it, that's sort of surprising. I think there's been a lot of things which have been I had thought was just my personal experience, but it's just been confirmed everywhere, which is that, typically a growth team or an ML team will be the starting place for experiments. The other thing that's interesting is, people have a wide variety of assignment regimes. Some of them are using Optimizely whatever. Some of them have, what they're called switchback assignments, where you, instead of sampling users, you sample periods of time. And that's something that you see at Uber and Lyft, et cetera. And then some people are just doing offline assignments. And what's nice about this data lake model is that it's all worked with our system. So, we see people doing those. The thing that has been, I would say, the most surprising, and this has been very pleasantly surprising, is that, when you look at all these commercial tools for experimentation, they usually advertise the high velocity of experiments. It's all about speed, speed, speed. When we talk to most experiment leaders, the people who are the kind of purchasers of these products, they didn't necessarily want a large volume of experiments. That itself was not desirable. What they wanted were better experiments, stuff that is, validating and invalidating hypotheses, stuff that kind of teaches you about, your customers and what they want, things that follow good practice, that follow rigor. And, it's cool because our system, because of the way we architected it, is well situated to deliver a lot of that. That was sort of a pleasant surprise. I think growth culture in a lot of corners gets this rap of essentially spaghetti at the wall. It's like just coming up with random things, putting it through a test and, trying to claim victory. But among the people like, heads of data, director of product growth, these sort of leaders, they want a much more of a intentional knowledge generating process and for people to essentially follow good hygiene reliably. So cool to see. So, we've actually changed a lot of the way we talk around Eppo to kind of emphasize that we are a tool that is well situated to, enforce good hygiene, put hypothesis first in terms of what you're going to test.
And as far as people who are using it, what are some of the most interesting or innovative or unexpected ways that you've seen it applied?
The most of the innovative, surprising things have been around, the ways in which people assign to different treatment groups. For example, we have one customer who they really want to have a handle over pre-experiment assignment bias. And they've taken it to a point where they actually just create 2 control groups. So every experiment has 2 control groups, which means they basically are running an AA test alongside every AB test. And so that's kind of cool. I think it means you have to devote a bunch of sample size to another control, but, it does give you some, good view on whether there's some bias there. Another thing that we see are people who are doing these offline batch assignments where it's like you have your big user base, you've done some offline process, maybe like hierarchical clustering or some way of dealing with stratified sampling. And then you want to, do analysis based on that. And what's nice is that, again, our underlying principle is just to live on Snowflake, BigQuery, Redshift. You can just upload that, we can just use that sort of offline assignment and just do all the analytics. So those have been kind of 2 things that you might call non-standard, but have worked pretty smoothly.
In your experience of building the business and technology stack and company around Eppo, I'm wondering what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think one of the things that has, again, been gratifying to see is I think so much of startup success comes from saying, who is your customer? Getting a really good definition around that. Who is what type of person, what type of job title, and what type of businesses are you trying to sell to? I think that especially in the technology world, the technical founders, you can see a little bit more of this, if I build it, they will come attitude. And generally, that's a hard, startup to build. But if you instead start from the opposite thing of saying, who do I want to build for? And then you talk to them and say, what do they need the most? Then you kind of naturally end up in a place that, fits the market well. So for us, I was pretty passionate around the kind of mid-stage growth company and selling to data teams. So that's kind of Series B, maybe late A, Series B to Series E sort of stage. And then selling to data teams, we naturally wanted to sell to consumer, prosumer teams. And so, that kind of fits a nice logical customer profile, and then, selling to the head of data, head of product sort of thing. And so when you have a lot of definition around that, a lot of great things come out of it. Your product decision making, your messaging, your resource allocation, a lot comes there. So that's been one of the big lessons that has continued to yield dividends for us.
In terms of people who are interested in being able to more effectively build and run and manage their experiments, what are the cases where Eppo is the wrong choice?
I think there's probably two ways in which Eppo might not be the right choice. So one is, if you're pretty early on, like if you don't really have enough sample size to run experiments, repeatedly, you might be better off with some sort of staged rollout feature flagging tool that basically just makes sure you haven't crashed the site, and that's it. We are trying to let you do a lot of different investigations, analysis, diagnostics around experiments, but it might be not as applicable if you just don't have the sample size to run a lot of experiments. So that's why, I said before with our customer, like Series B and onwards, kind of a nice spot for us. The other is if you don't have the modern data stack yet, like if you don't have Snowflake, Redshift, BigQuery, if you don't have dbt Airflow, we have built our system to be really native to that stack. So if your metrics are all sitting in, a Postgres somewhere, or maybe you don't have a database at all and you're just kind of reading, a clickstream off of RudderStack or something into various tools, that's also not a place we have built for. So, those are probably the two instances. Either you're too early and you don't have enough sample size to run experiments, or you are using a data stack that is not, your typical cloud data warehouse plus transformation layer.
And as you continue to build out the Eppo platform and business, what are some of the things you have planned for the near to medium term, or any capabilities that you're particularly excited to work on?
So, there's quite a lot of automations to keep building in. If you just think of all the reasons why an experiment might fail or come with caveats, like, we want to continue building these diagnostics and health checks. We also want to automate all the things that, a lot of this tool is built out of me trying to scale in the Airbnb experimentation culture at companies where there's only like 2 or 3 data scientists. So basically situations where experiment specialists are very bandwidth limited. And so I keep wanting to automate the things that, I had to keep getting looped into. So already we've made it very easy to introspect data quality to see is Eppo receiving the data appropriately? Has the table been updated in the past few days? Just basic sanity checking on data quality. But in the future, we want to make it so things like power analysis can be done before the experiment starts, kind of in that planning stage. We have all the, metrics, we have all the data, we can make a very good experience around that. And so that's going to come in the very near future, which we're very excited about. And then the other thing we're going to be investing more and more into is, I mentioned before, a lot of my formative background was building the knowledge repo. I believe experimentation is naturally a knowledge generating process, when done intentionally. And so if you think of the whole end-to-end journey of saying we need to figure out the right experiments to run, the stuff that, validates or invalidates the most important questions of the business, how do you organize in that way? And so it can look a little bit like, experiment epics like Jira or something like that. And then on the other end, how do you disseminate the results in a way that kind of spreads across the org and across time into the future? How can you make it easy so people can know what experiments have been run? This is all places I'm very excited to invest in.
Are there any other aspects of the work that you're doing at Eppo or the overall space of building and running experiments that we didn't discuss yet that you'd like to cover before we close out the show?
I just want to reaffirm the kind of broader point, which is why do you even run experiments? Why even have a data team, right? Because I think a big part of why I started Eppo was to say, the whole point of having a data team is to make good decisions. The whole point of running experiments is to make metrics a central, component of how you run the business. And experimentation, the reason we're all so excited about it is that it's a natural point of leverage for doing all of those things, for making a metrics-oriented point of view of product development, of product prioritization, become the DNA of the company. So as people are thinking around the different ways a data team could invest in different capabilities, and when they're looking at the huge variety of data tools available on the market from all up and down the stack, it's worth remembering, data teams succeed when they show clear impact and when they help establish their worldview of data as a central way of making decisions. And once you kind of get back to that central core of why have a data team, experimentation becomes a very natural place where you have to invest.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think, so much of this happens, it kind of similar themes to what I said before, which is that most of the data management kind of discourse can really center around technical problems and not organizational problems. No one cares about, the bar charts or line charts or, tables themselves. What people want to do is, make good decisions and, get ROI from their data team. And so I think what data management needs is a theory of change. Just what do data teams do in an organization? Why do they exist? So if you snap your fingers and make it you just plug a LookML block on a Snowflake with a Fivetran thing, if so much of this sort of reporting work is going to continue getting, very easy to do, I would guess you still need a data team to drive certain change and, what's needed there. So, obviously this is a very tightly connected to why I started Eppo and why I focus on experimentation. But I think data management discourse and discourse in general on data teams should, really get back to how is the data team going to have impact in an org? What change is it going to induce that will just help the company succeed?
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing at Eppo and your experiences of being able to build and run and manage these experimentation systems for businesses of various sizes and just a lot of the challenges that come along with that. It's definitely a very interesting and useful problem area. So I appreciate all the time and energy you're putting into it. And I hope you enjoy the rest of your day.
Absolutely. It was great talking with you, Tobias.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.